Sorry about the last video. Miss Musbauer called me, so I had to pause it and talk to her for a minute. So we're just going to continue on. So we're going to skip letter A for now. Okay, so we're going to skip letter A for now. We'll come back to that here shortly. Okay, example number 2. This is a prime factorization tree. Okay, I don't use it personally. There's a couple extra steps in there that I tend to forget because it's a little bit different than just listing them out. But if you can use this, go right ahead. Now, with the prime factorization tree, what you're actually doing is that you have your two numbers that you're trying to find the GCF for. Okay, so we have 12, we have 18. Well, when you're using a prime factorization tree, you're trying to find prime numbers that are factors of the two numbers or multiple numbers that you're looking at. So we have 12. So a prime number would be 2. Okay, so 2 times 6 gets you to 12. Well, 6 is not a prime number. So 6 has got to be broken down even further. So we have now 3 times 2 times 2. That equals 12. Now we have to do the same thing for 18. Well, 2 is a prime number, okay, but 9 times 2 equals 18. Well, 9 is not a prime number. So we got to break this down even further. So we get 3 times 3 times 2. If you notice, they both share a 3, and they both share a 2. So with a prime factorization tree, since you have two numbers, you have to multiply them. That's why I don't tend to use this step, because you forget to do that last step of the multiplication. So 3 times 2 would be 6. So the greatest common factor of 12 and 18, which is 2 times 3, that's 6. So you have to remember to do that last multiplication part if you're going to do the prime factorization tree. That's why I don't like it, because a lot of people tend to forget that step. I like just listing them out. Okay, so now that we've seen that, we're going to do a couple together. So we're going to jump over a couple pages, page 11. Okay, and we're going to do number 1. All right, so number 1 is 8 and 14. We're trying to find the greatest common factor of those numbers. So I always start with the first number, 8. Okay, I'm going to do it listing out all the factors. I don't like the prime factorization tree. If you do it that way, go right ahead. There's nothing wrong with that. I'm not going to stop you from doing that. It's easier for you, do it. Okay, this is easier for me. This is the way I find easy. If you find it easy, go right ahead. It's up to you. I just want you guys to do whatever is easiest for you to get to the correct answer. Okay, so now number 8, I always start with 1. Okay, I always start with 1. Now, 1 times what gets you 8? Well, that's 8. Okay, so I put that over there. So I'm going to put a comma here. Now, the next number, 2. Does 2 go in 8? Yes, it does. It's even. So 2 times what? 4. Okay, does 3 go in 2? Nope. But now we're back at 4. So we're done. Once you hit that other factor, that's why I do it this way. So if you hit that other factor, you're done. You can't go any more than that, because these are all the numbers that go into 8. Now, we're going to do 14. We'll do the same method. So we have 1 and 14. We have 2 and 7. Does 3 go in 14? Nope. 4? Nope. 5? Nope. 6? Nope. 7. Okay, we're back at 7, so we're done. So the ones they have in common are 1, 2, they don't have 4 and 7, they don't have 8. So your greatest common factor, the greatest number that they share, is 2. I know it's a small number, but sometimes that's the biggest number you can get. Okay, now number 2, we have 3 numbers. So we're going to do 21 first. So 1 times 21. Does 2 go into 21? Nope. 3 does. 3 times 7. 4? No. 5? No. 6? No. 7. Back there. Didn't need to leave that big gap, but sometimes you need to remember, because when you get bigger numbers, you're going to have a lot more factors. So it doesn't mean anything. You can cross it out, whatever. You can erase it, fix it. It's fine. You can leave it there. Now, 24. 1, 24. Does 2 go into 24? Yes, it does. It's even. So 2 times 12. 3? Yes. 3 times 8. 4? Yes. 4 times 6. 5? No. And we're back at 6. So we've got all our factors of 24. Now, 27. 1, 27. 2 doesn't go into it, but 3 does. 3 times 9. 4, nope. 5, nope. 6, nope. 7, no. 8, no. Now we're back at 9. So we have found all our factors of 27. So if you look, they share 1, they share 3, and that's all they share. So the greatest common factor, the GCF, is 3. Okay? So that's how you find the greatest common factor. So what I want you guys to do now, I want you to go ahead and to pause this video, and I want you to do letter A, back on page 8, and B and C. So pause this video, work those problems out, and then we're going to do it after you guys get done. So now that you've paused the video and you've done the work, we're going to go over A, B, and C together. So letter A, we have Lena earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount of money. Sorry. What is the most she could have charged for each bracelet? Well, we're finding the greatest common factor again. So this time it's just a real life problem. So Lena earned $49 on Friday, so that's where we're going to start. 49. Okay, so we have 1, and we have 49. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't. 5 doesn't. 6 doesn't. 7 does. 7 times 7. We're done. We've met all our factors. So now Saturday we have $42. So we have 1 and we have 42. If I could write. Okay, 2 goes into because it's even. 2 times 21. Okay, does 3? Yes. Well, a good trick to see if 3 is a factor of a number is to look at the numbers that you have, like the 42. Okay, now we're going to combine these two numbers. 4 plus 2. Well, that's 6. 6 is divisible by 3. So if the numbers that you have, so like 4 and 9, so 49. We have 4 plus 9, that'd be 13. Well, 3 doesn't go into 13. That's why 3 is not a factor. Now 42, we have 4 plus 2, that's 6. 3 does go into 6. So 3 is a factor here. Okay, well 3 times 14. Okay, so now 4, nope. 5, nope. 6, and we have 7. So we're maxed out on all our factors. We have found them all. Now we're going to do Saturday, 21. So 1 and 21. Okay, and then we have, does 2 go into it? No, we have 3. 3 and 7, and we're maxed out. So if you look, they have 1 in common. They have 7 in common, and that's it. If you notice, these do have 3 in common, these have 21 in common, but all 3 numbers have to have the same factor. So in this case, $7 is the most she could have been charged for a bracelet. So $7 a bracelet. Okay? So now, B and C. Okay, we're doing the same thing here. Okay, we're just gonna write them out, list them out. So we have 12. All right, so 1 and 12. 2 and 6. 3 and 4. And that's all your factors of 12. Now 66, this is a bigger number. This is gonna take a bit. So we have 1 and 66. 2 goes into it because it is even. So 2 and 33. 3, if we look, 6 plus 6, that's 12. Well, 3 goes into 12. So 3 is a factor. So 66 divided by 3, that would be 22. Does 4 go into it? No, it does not. 5, no, because it doesn't have a 5 or a 0 at the end. 6 goes into it, times 11. 7, no. 8, no. 9, no. 10, no. Back at 11. We have found all our factors. So you look, 1 in common, 2 in common, 3 in common, 6 in common, and that is it. So your greatest common factor of 12 and 66 is 6. Okay, letter C, we have 18 and we have 30. I don't know why it's not one right there, but so 18 would be 1 and 18. 2 goes into it because it's even, 2 times 9. 3 goes into it because 1 plus 8 is 9. 9 is divisible by 3, so 3 times 6. 4 doesn't, 5 doesn't, we are maxed out. So now 30. Okay, we have 1 and 30. 2 and 15, 3 and 10, and 5 and 6. So they share 1, they share 2, they share 3, they share 6, and that's it. So 6 is your greatest common factor. So that's greatest common factor. So that's when you're finding factors in numbers. Now we're going to switch things up a little bit and go to least common multiple on the next page. So least common multiple is when you're finding multiples of numbers. Basically, you're doing whatever number you have. So say you have 2 and 3, just like the next example. You're doing 2 times 1, 2 times 2, 2 times 3, 2 times 4, and down the line until you match that. And you want the smallest one now. Before it was the greatest common factor. Now it's the least common multiple. So there's 2 methods of doing this. One method is to use a number line, which there's nothing wrong with that. It's just going to be a little bit extra work to write all that out, and there's nothing wrong with that. It's a very good visual, because if you look on 2 and 3, okay, if you put a number line out, so 2 times 1 would be 2. That's why you put a red X. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. Okay, now the next one, we're going to do the multiples of 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4. So if you look, they have 6 in common and 12 in common. Okay, we are looking for the least, the smallest number, so that would be 6. 6 is our least common multiple of 2 and 3. So that's one way of doing it, the number line. The other way is just do the organized list again. Okay, there's not, this time all you're doing is listing out the multiples. So 2, 4, 6, 8, 10. Okay, 3, 6, 9, 12, 15. And then you're finding the smallest match they have. Okay, you can also use the prime factorization tree. And in this case, you have to multiply them all out. Once again, there's a lot of people that forget that step, and that's why it's very confusing. Okay, so if you do the prime factorization of 14 and 21, well, you break this down. You have 7 times 2. 21, you have 7 times 3. You have to multiply these all the way out. So 7 times 2 times 3, which is 42. Okay, so that's the prime factorization way. It's only if you want to use it. I'm not going to force anybody to do it one way or another. It's totally up to you guys. Whatever is easiest for you. Okay, so once again, we're going to skip a couple pages, go back to page 11, and we're going to go down. We're going to do number 5. So number 5, we have 5 and 6. So we're finding the least common multiple of 5 and 6. Okay. So on 5 and 6, we start with the multiples. So 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. Okay, 6 now. 6 times 1, 6 times 2. 6 times 3, 6 times 4, 6 times 5. So if you look, we don't share anything until 30. So 30 is your least common multiple. Okay, you're finding the smallest number they have in common. Before, it was the greatest number they had in common. Now we're finding the least number that they have in common. So we're going to do number 7 next. So 6, 12, and 15. Okay, I'm going to start with 6. 6, 12, 18, 24, 30, 36, 42, 48, 50, what am I thinking? 54, and 60. Okay, I'm just going to stop there for right now. So now the next one is 12. So we have 12, we have 24, we have 36, we have 48, and we have 60. Okay, so then 15, 30, 45, 60. So if you look, these ones share 12 and 12, but not all 3 have the same number. All 3 have to have the 1 in common. So we have 60, 60, 60. So 60 is your least common multiple. Okay, so that's how you're finding that. Sometimes it's going to be a bigger number, even though it's supposed to be the least common multiple. That's the only one they share in common. Okay, so let's go back, and we are going to do, so you guys are going to do E, and F. So you're gonna pause the video and you're gonna do E and F at the bottom of page 9. So go ahead and pause the video now, work on E and F, and then come back and we're gonna finish these out. So now that you've done these, I want you to go ahead and do so we're gonna do letter E together, so 2. So 2 and 6. So 2, we start with 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. So if you look, we share 6 and we share 12. Now, we do have 2 in common, but like I said before, we want the least common multiple. So the least is 6. So 6 is your LCM of 2 and 6. Now, letter F. So we have 4, 5, and 10. Now we have 3 numbers. So we're going to start with 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. Okay, and we always go more if we need to. Okay, now 5. 5 times 1, 5 times 2, 5 times 3. Whoa, I can't draw. 20, 25, and 10. So 10, 20, 30, 40. Okay, so we have 10 in common here, but not on that first one. We have 20 in common. So they share 20, all 3 of them, and it looks like it's the very least one, so 20 is our least common multiple, LCM. All right? So once again, you are going to be able to ask questions with myself live over Google Hangouts on Tuesdays, and we're still deciding on another time as well. So those are going to be an hour-long process. So if you guys get stuck on something, you guys can come and talk to me for that hour-long live session. That's the whole thing. You guys are able to talk to me about issues that you might be having or any questions that you might have. Okay, so on the next page, we're going to look at the last example, or example number 5. So Ernesto has painting class every 2 weeks. Kamala has a pottery class every 5 weeks. Ernesto and Kamala met at the art building for the class this week. How many weeks will it be until they see each other again? So if we're looking for the multiples again, so Ernesto does it every 2 weeks. So multiples of 2, 2, 4, 6, 8, 10, 12, 14, so on and so on. Now, Kamala comes every 5 weeks. So now we gotta do the multiples of 5. 5, 10, 15, 20, 25, 30. So if you look, 10 and 10. So the next time that Ernesto and Kamala will see each other again is in 10 weeks because that is the least common multiple. Okay, so that is a lesson number 1. Okay, chapter 1, lesson 1. Okay, the IXLs that you're gonna do are on the plan book. Okay, but you're also gonna be doing just one IXL that will be assigned on the Google Classroom as well. Let me get logged in. And you guys are going to complete 6th grade. So you're gonna go to 6th grade and you're gonna do E8 and E10. So both of those go along with chapter 1, lesson 1. They both are dealing with finding the multiples and finding the factors.